Hi everyone, we are going to look at lesson 2. Now some of these questions I do want you to try on your own independently, so we're not going to go through every question on here, and then for those questions you can check the PDF of the answer key that's posted on Google Classroom. So for the first page, question 1 here is review from lesson 1, so I want you to try that one on your own. And then for question 2, we want to remind ourselves about transformations. And so I want you to try question 2 on your own. So after you get those done, you can check the answer key online. But I do want to look at what we're doing today for lesson 2. So in last class period, we were introduced to our rational function, and we just want to clarify a couple features that can help us in the next couple of questions. So the graph that we have here is our parent function graph, which means this is the most basic rational function, and it is the graph of 1 over x. So we have a horizontal asymptote, and horizontal is left and right at y equals 0. So that would be right along the x-axis, and it's y equals 0 because if we were to move it, it would hit our y-axis. Then our vertical asymptote is up and down, and for our parent function, it is x equals 0. So for this right here is our vertical asymptote, and it comes down and hits our x-axis at 0. So I'm going to change colors here. Even if I were to shift it to the left, my vertical asymptote would still be vertical, and it would hit my x-axis. That's why we call it x equals 0 for our vertical asymptote. All right, so our anchor points are like the main points that will help us graph. So at 1, the y value of this point is positive 1. And at negative 1, the y value of this point is negative 1. At 1/2, we're looking right in here. I go up, and it looks like I hit my graph right at 2. And then I can do the same thing for negative 1/2, and it gives me negative 2. If I wanted to double check, I could take these x values and plug them in where x is. So 1 divided by 1/2 does in fact equal that y value of 2. And then at an x value of positive 2, it looks like this is maybe 0.5. And at negative 2, negative 0.5. If we can get those 3 points, or 3 points on either side of our vertical asymptote, that will really help us determine the shape of our rational graph. So underneath, I want you to try to match these without your calculator. So using transformations, which equation goes with which graph? And then you can pause the video. All right, we're going to talk about this because I'm going to talk about this, which will lead us into the next part, and the next part you're going to do on your own. So it says match each graph with the correct equation. I'm going to start with the middle equation here at B because I noticed the +3 on the outside. That is pushing everything up 3. So when I think about transformations, I'm going to scroll up. I'm thinking about this graph getting shifted up 3. And so my horizontal asymptote right here is also getting shifted up 3. So looking at my options, this graph right in the middle would be my graph for B because my horizontal asymptote got shifted from where my x-axis was up 3 units. Then I'm going to look at equation C. This x plus 3 is on the inside of our denominator, which means it is actually going left 3 units, which would correspond to our first graph. And then A would correspond to our last graph. And so this one has 3 in the numerator. This is a vertical stretch by 3. And we can think of it as 3 times 1 over x. And when we multiply fractions, we multiply numerators, and I can write this whole number of 3 as a fraction of 3 over 1. So going straight across, 3 times 1 is 3. 1 times x is x. So that's why it ends up in the numerator. And the difference here is instead of having our anchor point at 1, 1, it got pulled up to positive 3. And this is at 3. And then here, instead of at 1, 1, it got pulled to here. And so that's where that 3 comes in. So using what we talked about here, I want you to write equations for these 4. And then you can check your work with the key. I'm going to write mine in really quickly here so you can check it here in the video as well. All right, so for number 5, it got shifted up 6, so my plus 6 is on the outside of my fraction. This one went 2 units to the right, so I need x minus 2 inside my denominator. This one flipped, so my parent function is in quadrant 1 and 3, and it flipped to 2 and 4, so I need a negative in front of my fraction. You could also write it with the negative in the numerator. And then for number 8, if we know a vertical asymptote is at -3, that helps us. So looking at question 6, we had a vertical asymptote at +2, and our denominator was x minus 2. And the reason that is if I do x minus 2 equals 0, I get x equals +2, which is my vertical asymptote. So if I know my vertical asymptote in number 8, I know that my denominator has to be x plus 3, because if I set that equal to 0, that's how I get a vertical asymptote at x equals -3. Since the horizontal asymptote is still at 0, it did not get shifted up or down, so this would be my final answer. But if I wanted to double check, I could plug in an x value of -2, calculate it, see if I get that y value, which I do, and then the same thing for these points as well. So let's go through one graphing one. For number 9 here, I want you to match the rule with the notation, and then you can check your work with the key. But we're going to look at number 10. So number 10 says, graph the following equations without using technology. In reality, you will always have a calculator in this class. So we're going to start it without technology to understand the concept of what's happening, and then we are going to use our graphing calculators to find additional points to help us graph. Same thing on the SAT, you'll have access to a calculator the whole time, and Desmos, and so we want to know and learn how to use those. So for this one, I would recommend that the first thing we do is rewrite our equation. And you don't have to, but I think it would help me. And so I'm going to pull this one onto the back. So since I'm just moving it on the same side of my equal sign, it's going to stay positive. And this negative is connected to my fraction. So when I rewrite it, it looks like this. And then I'm going to go from there. Excuse me. So then I want to think about like transformations and asymptotes. So I kind of realized in the last question that I can take my denominator and set it equal to 0. And that will give me my vertical asymptote. So I would get x equals -3. And I can also think about it of my original vertical asymptote is at 0. And if I pull it left 3 units, it would end up at -3. So let's draw that in, and we're going to use a dotted line for our vertical asymptote. And then if I still think about transformations, this +1 is going up 1 unit. So my normal horizontal asymptote for my parent function is at 0. And if that gets shifted up 1, I'm at positive 1. So I'm going to draw in my horizontal asymptote at positive 1. I want to do my asymptotes first, so that's going to be step 2. So we already drew them in, but we'll add that to our list. We want to sketch in our asymptotes. And then I also noticed that there's a negative, which means there is a reflection. So that is helping me visualize what's happening. My graph will end up over here somewhere and over here somewhere. I don't want this to be my graph. I'm just kind of visualizing it in my head. I want actual points. So for step 3, let's add that into our list. Just kind of look and see, do you notice there's a negative? Is there a reflection? Then for the last points, we want to graph some points. So we can use our anchor points to graph, or we can utilize a table in our graphing calculator. But either way, we want to, graph some points. So I'm going to make a table. And since my vertical asymptote is at -3, I'm going to put that in the middle of my table because I want some points on either side of my vertical asymptote. So I'm going to do -2.5, -2, and -1. So 3 on one side, and I'll also do 3 on the other. And so if I end up using my calculator and I type in my equation into my y equals, I want to make sure that I'm putting parentheses around my denominator. So if I were to type that in, it would look like -1. I use my division for my fraction, parenthesis, x plus 3, close my parenthesis, because that's the end of my denominator, and then plus 1. And that's what it would look like in my y equals. So I can do that to get some points in my table. Do that real quick. So at -1, we're looking at 0.5, -2, 0. I don't have decimals in my table, so I'm going to skip those. I'll come back to them. -4, 2. And -5, 1.5, or 1.5. So for the decimal ones, and we could have done it with all of our x values, we're going to take them and plug them in for our variable. So I would do in my calculator, if I wanted to plug in -2.5, I would do -1 divided by parenthesis, plug in -2.5 for x. I still have that plus 3, close my parenthesis, plus 1. When I do that, it looks like I get -1. So I'm going to put that in my table. Then I'm going to plug in my other x value. So this -3.5. -3.5 would end up being 3. 3. So I'm going to add that to my table. And now I can plot my points. So -1.5 would be, let's do a darker color. Would be here. -2, 0. And then -2.5, -1. -3.5, 3. -4, 2. And then I can connect my dots, and I know that my ends will approach my asymptotes, but they're not going to get close. And that's why we want to draw those in first, so we kind of have a barrier and we know where to go. So that would be the graph of our rational function. So you can do the question underneath and the practice problems in this note packet.